So what about security, hijacking especially? So what prevents, or what is an effect to prevent like session hijacking? I don't know if there's a concept like JWT hijacking, or if there's two, let's say users logged in, what's going to prevent me from, sniffing around and then picking up and getting the other token?
So that's actually pretty similar to what happens with cookies. If you're sending a cookie through HTTP and not HTTPS, anybody can sniff it, get the cookie, and simulate it's you. In here, instead of sending a cookie, you're sending a header, so it's the same. If somebody that is not using HTTPS, you can sniff it. So the solution to avoid sniffing for the JSON Web Token is just using HTTPS, so that everything that you're sending is actually encrypted. And then regarding like local storage versus cookies, they're almost as secure. The only difference is if you're using cookies that are actually HTTP only, they cannot be used, they cannot be called from the JavaScript, which local storage can always be called. But that's like the only main advantage of security. But cookies have the problem of that you can do cross-site request forgery. And with this, with JSON Web Tokens and local storage, you can avoid that. So it's kind of like a trade-off between the two of them for security. Make sense?
I think it would be more secure if you change your token for every action. Because if somebody steals your JSON encrypted and sends it one more time, for example, to repeat, to buy something, yes? Mm-hmm. So it will still affect the user. So it would be more secure if we token every time change it for each action.
So you can have a different token per action, but I'm not sure it would add you like much more security. It would be analogous to having one cookie per action, and I think nobody is doing that. So the thing is that if you have one token per action, it's like a lot more work to create these tokens, because every time that you want to do an action, you have to send the username and password, get the token, and then send the token back. So it's a lot of requests, and it's a lot of latency that you're adding to your app. And I don't think it's worth for that very little delta of security that you're getting in exchange.
I have a question here. I am working on an app which has to support browsers which don't have local storage. Mm-hmm. What are your thoughts on having a token in like the scope in the app and have that be a part of the header?
So if you're not supporting local storage, you can actually use cookies. But it wouldn't be the same, because most regular web apps are using cookies as an authentication mechanism. Because what they are using is the feature from cookies, where if you're calling a request in the same domain, it will automatically send the cookies for you. That is what I think is not good. But if the person doesn't have local storage, you can use cookies, but only as a storage mechanism. So all browsers have cookies, and what you can do is you can actually store in client side that cookie, that JSON Web Token in the cookie. And then every time you need to do a request, you just get the token from the cookie and send it in the header. And that way, you're just using cookies as a storage mechanism and not as an authentication one. We actually, if you're using Angular 1, we have a library that's called Angular Storage. It's GitHub Auth0 Angular Storage, which basically does that. It uses local storage by default, but if local storage is not available, it will actually use cookies for you. And the other thing that it's doing is it lets you save objects if you want. If you want to save the parsed JSON Web Token instead of just like the plain text one. Make sense?
Kevin. So I may have blinked during your demo, but I was wondering where on the server side, when the JSON Web Token is being created, that secret comes in, and if you have any other recommendations for a strategy on coming up with what's the better secret to use, or how do you come up with that?
Good.
So I'm searching the code.
So this is the endpoint that we just called, this sessions create. What it's doing is it's checking that the username and password exist. Then it's actually looking in the database, so my in-memory array. And if the user exists and the password match, it's calling this create token function. This create token function uses this JWT, which is from the JSON Web Token library. And to this, you send this secret. So in the HMAC 256 algorithm, which is what I'm showing here, what you have is you have just one key, that secret, and you use that secret both for verifying as well as for signing the secret. This secret can be any characters you want. The harder it gets, the harder it is for somebody to copy. It's like when you're creating a password with one password. If you have like 25 characters, symbols, it will be harder to copy. But another nice thing that you can do with JSON Web Tokens, which I usually recommend, is changing the algorithm from HMAC 256 to RSA 256, because what that gives you is that it will let you have two secrets. One will be a private key, and one will be a public key. And that means that only one server can create these tokens with the private key, but then anyone can verify this with the public key. That way, you have the private key even more secured because it has to be in less places, and everywhere you need to actually validate it, you just have the public key, which can be public knowledge because it cannot be used to create tokens.
Question here.
Yep.
If you've issued a valid token and it's stored in local storage, how would you go about, if you don't have that same token referenced in a database somewhere, how would you invalidate that? So a user is abusing their privileges and you want to reject that token. What's the best practices for that?
So for that, every token has an expiration. And what you can do is you can, before it expires, if you're logged in, you can actually, there's usually an endpoint that is called delegation or something like that, in where you can exchange a token that is about to expire for a new token that is going to expire in like 1 day. And that way you're creating something that is called a sliding session. So if you have used Gmail, for example, if you enter Gmail every day, it never asks you to log in again. If you enter Gmail once every 2 weeks, it will always ask you to log in again. And that's because every time you log in, it's issuing you a token that lets you stay authenticated for like 2 weeks. If you want to do that, you can do it for like 10 minutes. And then you have a JSON Web Token valid for 10 minutes. When it's about to expire, when you have like 1 minute left, you call this endpoint, and you get a new token that has 10 more minutes. And that means that if you want to disallow one user, you just block that user, and when he's trying to get a new token, once it's about to expire, the server will say, no, you can't have a new token. And that's that's the nearer you can get without the database. That means that if you have blocked a user and your expiration is in 10 minutes, the user might have 9 more minutes of access that you wanted. And that depends on your application. If you can't tolerate those 9 extra minutes, then yes, you would have to create a database, store the tokens there, and be able to blacklist them. But for most applications, if you blacklisted it and it's like 1 minute token and it can use it like for 50 more seconds, it's not that important.
Question here. So you're able to decode the token into a JSON on the browser in your app. Were you using the secret there as well? Or how are you able to decode in the browser without the secret?
I couldn't understand. Could you speak a little bit up, please?
So you're able to decode the JSON, I mean, the token into a JSON in the browser in the app.
Yeah.
But how are you able to do that without the secret?
OK. That's because the payload that you see in the JSON Web Token is base64 URL encoded. That means that anybody can read it. So both the header and the payload can be read by everyone. So if you're using it like this, you shouldn't put sensitive information. You should put like user ID, maybe a first name and a last name, and that's it. No passwords, no keys, no anything like that. If you want to put sensitive information into the token, that means that you have to encrypt the content of the payload, which is also part of the spec, and you can do it. And basically, in this case, you would get the payload, encrypt it, then do a base64 URL encoded of that, and then sign it. But the only problem that gives you is that you won't be able to read the content of that JSON Web Token in the front end, but that's your objective in the first place if you're encrypting it. But the nice thing about JSON Web Tokens is that it gives you the flexibility to do that. Because the payload is free form. It's a free JSON. So if you want to encrypt it, you can. If you want to just use it, you can. That just works.
So in your example, you showed how a user couldn't get past the login page when they didn't have a token, but then you showed when you changed the name and they could get past the login page?
Yeah.
Is that a bug?
That was a question? Sorry.
Well, I mean, is that something you would not like to happen?
So
Basically, you were just checking for the existence of a token.
of course, you wouldn't want that to happen, somebody to change the JSON Web Token or to fake it. You wouldn't want that to happen. But the thing is, I wanted to show that because that can happen. If somebody knows about how the browser works, if they know about JSON Web Token, they can do it. But the important thing is that even though they can see the HTMLs, they cannot be able to call the APIs that you want to secure. So yes, the HTML will always be visible. Same for JavaScript. I mean, any page that is in a single page app will always be able to be visible if you're using it as a template. But the result of the API, which is what is important to you, won't be able to be seen. That's what I tried to show in the example, that even though I can change the JSON Web Token to a malicious one, that person can still see the HTML, but he cannot get the response for the awesome Chuck Norris phrases. Sorry if I don't see you while I'm answering, but I don't actually know who is asking. I just hear the sound from here. Yeah, I will see you. It's you're near.
Quick question.
Yeah.
What do you think with JWT, the approaches for single sign-on and single sign-out?
That's a really good question. So what we're doing in Auth0 for that is actually using cookies, because with just JSON Web Tokens, you can't have single sign-on. So what we are doing for that is you have like your single page app that connects to Auth0. Auth0 then goes to Facebook. Facebook will authenticate the user however it wants. It will return to Auth0. Auth0 will save a cookie in the auth0.com domain, not in your app domain, and then return back to your application, which is foo.com. Then imagine you have bar.com, and bar.com wants to log in. It will go and ask Auth0. Since it's a game Auth0, Auth0 will actually have the cookie for single sign-on, and it will authenticate the user, but that's the only solution you can get. That's actually why we exist and people pay us. I asked him to ask that. Thanks.
Any other questions?
Anyone else? Well, thanks so much, Martin.
Thank you.
So everyone.